So let's look at some reactions that you need to know for your next organic chemistry test. So let's say, yeah, I was going to write reaction, then I realized I've just said it. So let's say you had a nitrogen on top. Let's say you have this molecule where there's a nitrogen on top with a hydrogen attached to it on the side. Then you have a CH3 on this end. And then on this end, you have another nitrogen with two hydrogens this time. Okay. And let's say you have a molecule which has a nitrogen on top. So let's say nitrogen here on top with 3 bonds connected to a carbon. Then you have this scenario. Then you have O ETO, which is actually ethoxide. Okay, then you have this situation. So let's say you added these and the reaction conditions required you to use, let's use a straight arrow since we're doing an overall reaction. So say the conditions you're given are these. So you have the ETO, which is the base, and then you have basically the base, yeah. And then you also have its source. So you have this, so let's say this was the problem, okay? Meaning that your product should be nitrogen, still with a double bond, okay? That's CH3, even though I've not indicated there. Then you have a nitrogen here, and then you have that going up side, just like that, okay? Then if you go up like this, you have a nitrogen with 2 hydrogens like that. So let's see, how do you go about solving this kind of a problem? So that's what we want to see today. So just in the interest of time, I'm just going to rub this whole thing out so we can get started straight away. See how we can get our product. So the first thing that we're going to do is use the lone pairs on the nitrogen to attack this carbon, making electrons to fall onto the nitrogen like that. Most of our reactions are reversible, so we're going to say forward and backward. We're going to use this sign a lot of the time. So that we have the nitrogen here. I'm going to make the hydrogen stick out like that, and I'll explain why. So you have the nitrogen here still with the double bond, then the CH3. So if you want, you can add CH3 there, there's no problem. Then you have nitrogen with 2 hydrogens in that way, okay? Then where this nitrogen and carbon have reacted, there's going to be a line to show a connection that they have connected, okay? Then, so we can use a different color just for some people may find that helpful. So we are showing a connection between this molecule here and this molecule here as well, because they have reacted with each other, okay? So then at the end of this line, we have the carbon, which we have here. Then on top, we are going to draw a double bond, right? With a nitrogen like that, and it will have a minus sign. Why? Because nitrogen usually likes to have 3 bonds. So it will have, when it has 2 bonds, it will have a negative sign. When it has 4 bonds, like in this case at the bottom here, it will have a positive sign because it's got more than what it actually likes to have, okay? So that's what we have here. Then we are going to draw the rest of this molecule here in such a way that we are showing that we are actually closing the ring. So we are starting from here, 1, 2, 3, and 4, isn't it? So, sorry, 1, 2, and 3. So we have, this is the first carbon, so 1, and I'm going to draw a straight line, then 2, so 1, 2, on position 3 there. So this, I would like to emphasize, should be your, this is a very important step. The step that I'm trying to emphasize here is the situation where NH2 looks at an O2. If you know the NOR synthesis in previous classes, we've looked at this. You'll find this situation often repeating itself over and over again. So this is it's no different even in this situation. So please take note of that. So when that takes place, the next thing that we're going to do is we're going to have what is referred to as a proton transfer. So I'm going to write the word proton. So proton, then transfer at the bottom. Proton transfer between what? And what is a proton to begin with? When we say proton transfer, a proton really is a positively charged hydrogen. That's a proton, okay? And it's being transferred between this nitrogen here and this nitrogen here. Basically, the electrons which are negative will abstract. That's the word they use. Will grab. Whoops, sorry about that. Will grab the hydrogen, causing the electrons to fall. We'll grab the hydrogen from this one at the bottom, causing the electrons between this hydrogen and that nitrogen to fall back onto the nitrogen like that. But since we've written proton transfer, we won't need to show that step. So we have nitrogen here now with a single, with an extra hydrogen. So it will lose a negative charge, Maybe if I could push it on the other side so that we can have more room. So you have a nitrogen here, okay, going down like that, then down like that, perfect. That's the way we need to write it so that we have a lot more space. Here there is an ETO, so please don't forget. And then to our left, or my left, we have a nitrogen here. Let's do that again so that we have good space. We have a nitrogen here, then you have the double bond, and then you have the nitrogen here as well with the hydrogen like that. Of course, still having that situation. So that's what we have there. The next thing that's going to happen at this point is that, and I like using the red pen, the nitrogen will attack the oxygen, causing electrons to fall onto the oxygen like that. So we're going to go downwards from here, okay? So that we have, so we're going to draw the same molecule. So nitrogen still with a double bond like that, going down like that. So there's now a connection between this nitrogen and that carbon. So we can even count together. So this is going to be, nitrogen will be 1, okay? Let's use this. So this will be 1, then this will be 2. That doesn't look like a 2. This would be 2, that would be 3, that would be 4, that would be 5, that will be 6, right? So it means that our nitrogen will be all the way at the bottom, right? So we have the nitrogen still with the 2 hydrogens sticking out like that, having a nice time in the solution. And then you have, of course, a positive charge there because now nitrogen will have 4 bonds rather than the 3 it likes to have. And then to the right-hand side, we have the oxygen with a minus sign, okay, showing that it has 1 bond when it likes to have 2. Then we still have our O and then E and then T like that. Going to this end, we have again the nitrogen with the double bond, right? Then you have the CH3, and there you have another situation here. Then just like we had a few steps back, actually the step before this one, we're going to have again a proton transfer between the nitrogen and the oxygen. So again, you go this direction, forwards and backwards, okay? So we have nitrogen there, and then you also got the nitrogen and the hydrogen connected to each other like that, going down like that as well, CH3. So there'll be a proton transfer, and I'll write that very shortly. So just bear with me. So nitrogen like that. And then you have also going down this side, this side. So the hydrogen will go onto the oxygen like that. Then here we still have our ETO, right? Or our OET. So here, make sure you indicate proton transfer. Okay, it will save you the work. We usually have proton transfer in what is referred to as intramolecular reactions, where it's within the same molecule, where the hydrogen is moving from one end to another end. So that's where we have what we refer to as a proton transfer. Okay, so proton transfer there. Then the next thing that we're going to do is to remove our hydrogen here. So we're going to introduce our base, okay, with a negative sign, the one that we started with at the beginning, if you recall. So the base here is going to remove this hydrogen, causing the electrons to fall here, and then at the same time removing that ETO there. Okay, oops, sorry about that. Then we have this one is more, it's favoring more the forward reaction. So we can even have that situation. And then we have, of course, the nitrogen here with a double bond going sideways, going down like that. So now the nitrogen is all by itself. And here on the end, on this end, we have our final OH, right? Then we've got also our nitrogen here, double bond, like so, like that. And then you have that situation, CH3 still there on the side. Then our final, second last step will be this nitrogen here abstracting. Let's use a different color. So this nitrogen here abstracting a hydrogen from the solution, right? So just for simplicity's sake, I'm going to use the oxonium just so we don't get too confused. Or we can just go ahead and use this one. There's still no problem. Okay, but you can use the natural, the ordinary, you can use the ordinary one. Like the one I was intending to use was this one. Okay, we have this one here. And then going on here, we have that situation there, right? So let's use a black pen so that we could have a bit of consistency. So we have the positive charge there, circled by that going on there. Perfect. Okay, so basically, once that takes place, you are going to have this situation. So going to get going to have a new page, brand new page, and the nitrogen on top will have 2 hydrogens this time. Okay, and it will be positively charged. Okay, so we'll circle that later. So let's just go ahead and indicate all the other molecules going down. Okay, then this of course is like this with the OH, if you recall. And then you also have the double bond here going this end, you have a CH3, and then there you have a thing, the bond there. So remembering that there is a hydrogen here, which has always been there, by the way, we're just bringing it out because it's important. Just like here, we're bringing this hydrogen out because it's important in our next step. That's the reason why I stuck it out, unlike in the first case here. So what's going to happen is that a base, okay, very strong base will come. So the base we're using is ethoxide, right? So the base of ethoxide will come to abstract this hydrogen, forming a double bond. Then this double bond will also break, leaving a single bond there. And then you have a situation where this is the case. Okay, so we're going to have this one more forward than, because it's actually the final step, I believe. Yes, it's the final step. Okay, so you're going to have CH3 there, and then you also have a nitrogen on the side Going up there, you have another double bond. So that's basically how you do this particular molecule. Okay. So that's how basically you do this particular molecule with the CH3 there, of course. And we have this going on there.